Hi, in this video I want to discuss some of the answers to the map application questions that were asked in the 2013 A-level exam based on the Usk map from South East Wales. To answer these questions, first of all we need a little background about the geology of this particular area. So we've got a photograph of an exposure from this location. And the first question is a fairly straightforward one, just looking at scale and the direction the camera was pointing. This is just get your orientation of, in particular, of dip sorted out. So if we measure the hammer, scale it up, it's about a 2 meter high section, but any answer between sort of 1.5 and 2.5 meters is fine. The camera was pointing east because we can see that the dip here is going down to the right. If you look on the map, if you like, line yourself up with a direction where you'll have a dip to the right, that'll show you that this camera is pointing east. The next question then is a fairly straightforward one again, just to annotate figure 5 to show two different geological features. Now there's a number of things to go at here. We could be looking at, we've got this gentle dip. If you measure it, it's about 10 degrees. We've got these structureless beds. There's no sedimentary structures obvious within them. The bedding planes, though, are fairly irregular. We've got these vertical joints and fractures within the rock. There may well be erosion surfaces here which might account for these irregular bedding planes. There are some areas that have been more weathered than others less weathered, and you might get you'll get credit for anything else that's sort of vaguely sensible. You can see there's sort of an orange lichen on top of this limestone, which could well lead to some biological weathering going on. But certainly I think you need to be discussing the bedding plane, some aspect of the bedding within this outcrop as the most obvious geological feature. The next question then gets more into our use of these rocks. And in particular, notice how the question specifically says to refer to figure 5. So referring to that photograph of the outcrop to show you what this rock unit is like. You've got the geological map and you've got the cross-section to consider. Now we need to assess this Wenlock limestone as an aquifer. So the examiners here have given us 3 things to talk about and 3 marks. Okay, so we need a good point for each. Now we could talk about the fact that this particular unit would be suitable. Clearly this limestone is permeable. We've got the vertical joints, we've got horizontal bedding plane, water has pathways to move through that rock. Above and below we have low permeability rocks, siltstones and mudstones. So any water that's in that limestone could well be under pressure. It could be an artesian aquifer, or a confined aquifer would be another way of describing that. And in some places here we do have synformal structures. There are basins to trap water within this rock unit. And as well, we have an outcrop on the surface. So rain falling in this area can replenish, can recharge that aquifer. And we don't see that much evidence of faulting. The chances are these beds are fairly stable. You may want to argue that it's not completely suitable. The limestone itself is a relatively thin bed. It's only, if you measure on the generalized vertical section, about 10 meters thick. So there's going to be limited amounts of water that can be stored. The surface outcrop isn't particularly large either, as you might expect from a thin bed, which is going to limit the amount of recharge that can occur. And there are some places where you do get an antiformal structure, where water is going to flow away in a down dip direction. And although there might not be much of it, there is still some faulting in the area. Those faults may be reactivated by water in the rocks. Although you could argue that that water will be there anyway, whether we choose to pump it or not. The final question then goes back to this idea of slope stability. We have a fairly large mass movement here, and it's asking you to evaluate these different factors that may well be responsible for the landslip. Again, the examiners are breaking this down for you. Use this structure. Let's see how we can do that. So the dip of the beds here. The dip here is going to be a very limited factor. If we look at the dip amounts, they're all, again, very gentle, 10 degrees or less. That's going to be below any basic friction angle. The dip is into the slopes. It's very similar to the exercise we were doing on Pendle Hill. That makes the dip certainly stable in terms of a mass movement. But there could be some lubrication or pore water pressure here moving along those dipping bedding planes. Any two things there will get you the mark. Will get you 2 marks, should I say. We're also asked about fluvial conditions. What's actually going on with the river? We can see in this particular location, around the toe of this landslip, we've got a river. It's marked by that pale yellow alluvium deposit. Alluvium is river sill, floodplain deposit. It could be a possible factor in that the river is undercutting the toe of this slide, the base of this slide, undermining. It could be the water then affecting the hydrological system. Perhaps water from the river getting into the limestones there, lubricating those boundaries, reducing the friction that's there. Any two of those factors can get you the marks. The third one we had to consider was faulting. This again is a possible factor. We may have, there are clearly faults in the area of this landslide. Movement on those faults, some reactivation, some type of dynamic movement can act as a trigger for already weak rock. There can also, of course, be pathways for water. So there's quite a lot of different factors there we can analyse, but nothing there is particularly new to us. So, as we see the sun start to set over the River Usk at Crickhowell, key takeaway from this is that when we're working on these map work questions, they're an integrated whole. They're all asking about the same rocks in the same area. So if you've been developing ideas and answers as you work your way through the questions, you may need to use that information later in the paper to be able to give yourself maximum chance of getting those marks. So don't forget the answers you've written. And again, use the structure that's given to you by the examiners. It's there for a reason. Take the helping hand. If you've got any questions, get in touch. I'll see you next time.